Okay, so let's go ahead and get started. On Monday, the class was a little bit different in terms of formatting than it's typically going to be. I lectured almost the entire time because we hadn't done anything yet, and I wanted you to have some background. But from here on out, primarily what I'm going to be doing is I'm going to be working one of the questions from the homework to start with, and then we're going to have our classwork that we're going to do the rest of the time. Now, the way that the classwork is going to work, I intentionally tried to give you more problems than you would be able to finish, but when you submit it and when we grade it, we're going to grade what you're able to complete. So don't worry too much if you don't get to all of these questions. Okay, so to start with, we're just going to go over this question that we had on the homework. And that question said that if you have some charge Q1 is equal to 2Q at the origin, and you place some charge Q2 is equal to minus Q at the point minus A minus B, we want to find the force that, I actually don't remember which one I did first. Was it 2-1 first? Okay. The force that 2 acts on 1 is going to be equal to 1 over 4 pi epsilon naught Q2 Q1 over R squared times R hat to 1. Okay. So when we look at this equation, we realize there's several things that we need to figure out here. We're given what Q1 and Q2 is. We'll just end up plugging that into the top part of this equation. We need to figure out what R is and what R hat to 1 is. So to start with, what we can do is we can draw the line that connects Q1 and Q2 and label this as R, right? That's just the distance from Q1 to Q2. And then we can draw a line here to make a triangle. And then when we do that, what we see is that this portion right here is some distance. Let me write this bigger so you can see it in the back. This is some distance A, and this is some distance B, which means that R is just going to be equal to the square root of A squared plus B squared. Okay? Now, the next thing that we need to do is determine what this unit vector R hat to 1 is, and by definition, that's a unit vector that points from 2 to 1, and so I can draw that in right here, and I can put in some angle of theta. Okay. Now, that angle of theta is going to be the same angle of theta that I have here, which means that, well, I'll get to that in a moment, but what we can do to start with is we can just write down R to 1 generally is going to be equal to some amount in X plus some amount in Y. And now our job is to figure out what this amount in X is and what this amount in Y is. So based on these triangles that I drew, this portion is going to be the portion that's going to be in X. This portion is the portion that's going to be in Y. And so what that says is this is going to be some cosine of theta, and this is going to be some sine of theta. Now, because we introduced this angle theta while we were working the problem, it wasn't something that we were given. We need to parameterize this cosine and sine in terms of the things that we do know. And so that's to say that we need to figure out how we can write cosine and sine of theta in terms of R, A, and B. And so looking at this triangle here, we know that the cosine of theta by definition is the adjacent over the hypotenuse, and so that says that this is A over R. Sine of theta is going to be the opposite over the hypotenuse, which is going to be B over R. So this says that this is equal to A over R X hat plus B over R times Y hat. And now the last thing that we need to do is just to put all of this together to find what F vector to 1 is. And so that's to say that this is going to be F vector to 1 is going to be equal to 1 over 4 pi epsilon naught. Q2 is going to be a minus Q. So this is a minus Q. Q1 is going to be 2Q. R squared is going to be this quantity squared, which is going to be A squared plus B squared. And then we just need to multiply our unit vector here. And so this says that this is A divided by A squared plus B squared to the 1/2 times X hat. plus b divided by a squared plus b squared to the 1/2 times y hat. And then we can put a box around that. And that's going to be our answer for the force that 2 acts on 1. Now, I don't remember what order I asked these questions. Did I ask for 1, 2, second? Yeah. So now what we want to do is we want to determine what the force that 1 acts on 2. And I said there's 2 different ways that we can do this. The quick and easy way to do it is to say, well, we know that from Newton's third law, there's some equal and opposite pair of forces here. So whatever force 2 acts on 1, the force that 1 acts on 2 is going to be equal and opposite. And that's to say that F vector 1, 2 is going to be equal to minus F vector 2, 1. Okay. Now we could also go through the same process that we went through here in order to determine what F vector 1, 2 is explicitly. And when we do that, what we see is everything on the right side of the equation is going to be the same except for the unit vector, right? Because this unit vector, the first one that we had was r hat 2, 1. The second one that we're interested in is r hat 1, 2. Okay. So r hat 1, 2 is going to point from this one to this one. So it's really just going to be in the opposite direction. And that's to say then that r hat 1, 2 is going to be equal to minus r hat 2, 1. Okay. And so from these statements, we can see the 2 different ways that we can do this. Okay. So the last thing that I asked was, does this jive with the way that we understand conceptually how these forces are going to act on each other and whether they're going to attract or repel based on whether it had positive charge, positive negative, or negative negative. So we see here that we have some negative charge Q2 and some positive charge Q1. These are going to attract each other. And so the force that this one experiences should pull it down towards this charge. So ultimately, when we look at our calculation here, we see that we have a negative sign times our x hat and a negative sign times our y hat, and that's going to make it go down this way. We would say the same thing when we look at the calculation for F vector 1, 2, that ultimately the way that the signs work out, it's going to pull it up this way. Okay. So any questions about this? Yeah. So
just to clarify things, when you determine the sign of cosine and sine, so it doesn't matter which quadrant you are, it matters which direction you move?
Exactly. So just to clarify what you're asking, when you say what quadrant you are, you mean where the charge is? Yeah, it doesn't, it kind of ends up being true that, but yeah, it depends on which force you're finding, not so much what quadrant you're in, because we see that this is in the third quadrant. If I'm finding the force that this acts on this, then my unit vector is going to point this way. But if I find the force that this one acts on this one, it's going to go this way. So it's not necessarily the quadrant. It's the which charge am I finding the force on. And always, and we're going to get even more practice with this today and going into next week, that the rule is always what is the charge I'm trying to find the force on, and what the unit vector by definition is going to point at that one. Okay. Other questions? Yeah.
So do you have to be pretty careful about which angle you choose among similar angles? Like you can't just indiscriminately choose like the upper corner of that theta on the opposite side.
Oh yeah, you could. So I just made a choice here. So I could have instead, I think this is what you're saying, choose this one?
No, I was saying like if you chose the similar angle on the opposite side of the line. Like the,
oh, you mean that one?
If you chose that one, you'd end up with the wrong, would you end up with the wrong?
No, it still works out the same way. It's just that you draw the triangle a little bit differently. So let me Walter Loomis. Yeah, that doesn't work very well. Okay, not on this board. It's a fancy way to draw dotted lines. So you see how I have, that would be the triangle if that was the angle that I used. And then I have, let me just kind of dot these lines. And then I have the other triangle. It actually doesn't matter. And also, the thing that I thought you were asking originally, did it matter which angle I chose? I could have chosen this angle, in which case I would use this angle, and then instead of being cos theta, this would be sine of phi. But then when you go through to do the replacement, it ultimately ends up being the same thing. So it's ultimately just a choice that you make, and as long as you're consistent with that choice, you'll get the right answer.
Okay.
Yeah. Other questions? Go on, try something. Yeah, sure.
Follow up on what
Sure.
I was asking. And the reason I was asking about that is because when I tried to go through and solve it the first time I was looking at, I used that top angle. I ended up with my sines, my positive and negative on my cosine and sine flipped. I ended up having the force pointed in the wrong direction, which is because I was thinking, okay, if the angle's pointing this way, so the sine's going to have such and such a sine, and the cosine's going to have such and such a sine. You just have to kind of put that in a different layer of the process, then, or
Well, right. So yes, whenever I'm finding what sine and cosine are, I'm treating these as magnitudes, right? Because you're right. When I look at this, if I'm trying to say, well, this kind of makes an angle like this, and that would make me want to draw a vector that looks like that and that, right? But that vector that I'm drawing here is actually not the one we're looking for. That's really the vector that points from here to here.
Yeah.
So when I put in my positive and negative signs by hand, and I suppressed a positive sign here. But the reason why I made this positive is when I look at this is the positive x direction, this is the positive y direction, and then I just put in absolute value cosine, absolute value sine here. And when we did this portion here, I didn't show this explicitly, but when I would look at this one here, this would be theta, and then this would be in the negative x direction and negative y direction. So were I to explicitly write down what r hat 1, 2 is, I would say that this is minus cosine of theta, x hat minus sine of theta, y hat. Yeah. And like I said, we'll get more practice with this as we go today. Any other questions? Okay, so go ahead and get started working on those worksheets. You're welcome to work with anybody around you and argue amongst yourselves about who knows how to do the problem or not.